In this demo, I'm going to show some of the LayerCake frameworks. I'll start out with the Android framework. So let's go into the Android folder. And there are a few files here. The XML file is an Android file you need. The Android layer definition file, which extends the same extended model layer that we saw in the Swing UI, but then it also extends some Android framework layers. And then there's the unit converter source itself, which looks like the Swing version, only it extends the activity class for Android instead of Swing class, and then it uses a row column layout that's built into Android, this linear layout component. And then there's components like the CSpinner and cEdit text, which are lightweight extensions of the Android classes that add data binding to a couple of properties. But otherwise, it's the same way that we bind the fields to the model, and so it actually has the same structure and flow as the Swing UI version. And to run this version, I can just run, I'm in that folder, so I can just run lc dot. And this Android framework doesn't support dynamic mode, so all it's going to do is actually compile the application for us. It takes all of the project files that exist in the framework layers and copies them into the build directory, and then runs the Android build in the build directory, which it's now just installed that onto the Android simulator. And the nice thing about the way this file works is that in each, you don't notice there aren't a ton of Android project files in this folder. We're getting those from the framework layers. But if we wanted to override any file, we could just add that file here, and it would use the version for this project instead of the one that's either getting copied or getting generated dynamically. So now I've compiled and run it. So let's go to the simulator and actually see the end result. And go down to the unit converter, and we run it, and the awkward keyboard, and so it works just like the Swing version. Okay, so that's the Android framework. Let's go now to the Wicket framework. So Wicket is a web framework, and I'm going to go to the Ajax version of the unit converter on Wicket, and the layer definition file just looks the same. It extends the extended model, and then it extends Wicket's core layer, and then the unit converter.html file is a static HTML file, but with these Wicket ID attributes. So here we're tying a DOM element to a Java LayerCake component with the same name. So the name will be unit converter form, and then the other one here is converter choice and unit one label. So let's look in the LayerCake file, because that's where the dynamic components are defined. And the top level class here extends Wicket's web page component, and then you see unit converter form down here extends Wicket form, and then the converter choice, unit one label. These are the components that generate the dynamic content that replaces the children in the HTML file at runtime. So let's run this, and so it started up the server. Now I just have to bring up a web browser, and I go to localhost 8080, and this is the Wicket sample using their Ajax mode. So interestingly, the way this works is that when form fields change, JavaScript code sends that down to the Wicket server. We apply those changes to the components that we set that receive those changes. So in this case, the field, and then the field runs the data binding expression, which invalidates the DOM for the other field, and then those invalidated HTML chunks are sent back to the client afterwards and patched into the DOM on the client. So the data binding here is actually all running on the server, and only the changed elements are sent back to the client. So even if there was a big page here, the system and data binding is used to automatically say figure out that when the converter changes to send the HTML for both the labels and the text fields, but when only the text field changes, it only has to send the HTML for the other text field. So it's kind of nice that the declarative model has that enough information to do that accurately. Okay, so that's all I want to show for Wicket. Let's do the last framework I want to show is GWT. And in GWT, it's the simplest one of all. The layer definition file again uses extended model, and GWT main. There are no other project files. There's just the unit converter class, and it uses an annotation, not a base class. And then it uses GWT components for layout, list box, flow panels, and again there's some wrapper classes like this ctext box that just extends the GWT version and adds some events for data binding. And here, the data binding looks exactly the same as it did in the Swing version. So that's the code. So let's run it, and we just run the LC command again. Since we're in that folder, I don't have to type the layer name. And now it's going to start the simulator, and I have to launch the default browser. And it's actually now compiling the Java code into JavaScript using the Wicket. So this is Wicket's overhead here, and one of the problems with the Wicket framework is it's fairly complicated and takes a while to compile. So it's doing lots of optimizations. But now, once it's compiled, it looks very much like the Wicket one, but in the GWT version, it's running entirely on the client, so there are no server calls made here at all. All the data binding code and stuff gets converted from Java to JavaScript, and when I make a change here, it evaluates the data binding expression and updates the DOM using the GWT framework. So let me just spend a minute talking about why I don't really want to keep working on both the GWT and the Wicket versions. In the GWT case, it's a complex framework and it's unidirectional, so you can use JavaScript from Java, but you can't go the other way around, which limits use of frameworks like jQuery and makes it hard in the case where the simulator doesn't let you debug the code. You've got this complex generated Java code that's all optimized and hard to read and debug. So I don't think it's quite the best solution, and it doesn't. And then Wicket on the server side has got some complexity in how it manages state and things, and it doesn't quite let you layer HTML and Java as simply as it could. What I want to do is kind of use a combination of both approaches, and since LayerCake has code generation capabilities, I can generate JavaScript in a flexible way from the Java code, so I can use jQuery and other frameworks, and then I can have client layers that run on the client that get converted and server layers that run on the server, and then the overlap, say layers that are both on the client and the server, those layers I can synchronize the objects and just those slices of the objects between the two layers. So it'll be one declarative model. Some of the components will run on the server and will patch the DOM the way Wicket does. Some of the components will run on the client and won't talk to the server at all unless they need to synchronize. And when they sync, the overlapping pieces between the client and the server application are already known to the framework. So I can manage that synchronization automatically, giving you kind of one declarative model that spans client server, but without compromises, and that it will support a dynamic mode which can patch the code on the server in real time and generate little JavaScript snippets that then patch the code on the client as well. So or refresh the page if the changes you've made don't lend themselves to an incremental refresh. So I'm excited about the potential for this kind of framework that combines the best of Wicket and GWT, and that's what I think LayerCake needs next. So the next demo, if you want to see how frameworks are implemented and more about the architecture of LayerCake itself and why it's kind of unique and interesting, take a look at the next presentation, and thanks for watching.